So let's look at part 3. Now the corresponding value of x found in part 2, it's called the optimal point. The corresponding value of theta is called the optimal angle. So explain why a player may decide not to take the kick from the optimal point. Okay, now let's try and understand the question here. So the optimal point is when we optimize the angle, means when theta is tangent theta is max. Okay, maximum. Now, when tangent theta is maximum, it also means that theta is max. Alright? Because this is in the first quadrant. So anyway, why do we need theta to be maximum? Because if, say, you have a... Okay, now this angle here will give you the trajectory of the ball to go into the... to be scored within these two poles here. Right? So if you have a larger... larger theta, okay, it means that you have lesser room for error, so lower margin of error. So if a large theta, and then this is a small theta, so we need to understand this first, okay? So the reason why we need to maximize theta is because you can just imagine if you have a larger theta, meaning to say you have lower room for error. So it only makes sense then, okay? So how do you actually think about it? So of course here you have a very small angle here as compared to here. This has a larger error. So this angle here is larger. This is smaller. So you wouldn't want to squeeze yourself to the end there. Okay, but the problem now is this. Now since you have lower room for margin of error, why a player may decide not to take the kick? Okay? So one thing I would suggest you to think about this game is you think about from relate it to a real life game. Okay, this game here is actually like rugby, American football. Once you score the scoreline here, you can actually kick into the two poles there. The problem with this calculation here is we are only considering the calculation based on this plane, meaning on this field here. So it means you never consider how high you want to kick, right? So you have to consider what is the rule for kicking into these two poles. Like it may be an optimal angle here, meaning this is maximum, but this angle of elevation is going to be immense as you get closer to the poles. Okay, it really depends on how high you need to kick as well. So one of the reasons why, which I think is a pretty solid reason, is we didn't consider the angle of elevation. Okay, so this is what I'm going to write. So basically, part 3. Our calculations of optimal angle and optimal value, right? Optimal point is based on the plane x on the xby. Okay. We did not consider the angle of elevation required for the ball to be kicked between two fixed poles. Okay, so for example, that is, if there is a minimum height to be attained, okay, the closer k is to xy, let me just write this down, closer, the larger the angle of elevation required, okay, to score. Hence causing the kick to be more difficult. Okay, this may thus the player may decide not to take the kick, okay, from the optimal point.